Now we focus a little bit more on right triangle usage. In right triangle usage, and we have, essentially the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We use that kind of terminology when we have a triangle diagram that isn't necessarily formed from me having a triangle, drawn using coordinate system information. Um, so when we're dealing with that kind of circumstance, keeping these straight is very important. Now, opposite and adjacent are the names of the two legs of a right triangle. And opposite and adjacent is going to depend upon which angle you're focusing your attention on at a given time. Don't get into a habit, because some students do, and I try to make sure they don't get into this habit, but I always have students that do. Adjacent is not always going to be the horizontal one, and opposite is not always going to be the vertical one. It depends on the angle on which you're focusing your attention. So when I look at, the example 14, I don't have any measurements given down there. I just have angles A, B, and C, and I have sides A, B, and C. And in trigonometry, if I'm using single letter designations for sides, side A should always be opposite angle A, side B should always be opposite angle B, so forth and so on. Angles are given in uppercase letters, whereas sides are given in lowercase letters, if I'm using single letter designations, that is. So when I say the sine of angle A, well, I'm focusing my attention on angle A at this point. B would be the hypotenuse, A would be the opposite leg, C would be the adjacent leg. So when I look and do the definition and say, okay, well, that's going to be opposite over hypotenuse, that's going to be A over B. And if you haven't remembered it already, I don't know if I have it appearing on these notes here. There was a mnemonic device for the sine, cosine, and tangent called Sohcahtoa. Sohcoh or Cahtoa, and that stands for sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I know there are some textbooks that would even go into further detail about Sohcahtoa was the name of a Indian chief who lived on the geometric planes, and they lived in right triangle teepees and all sorts of ridiculous things that made me feel like if I was trying to teach, I'm not I feel like I was teaching kindergarten, not teaching trigonometry. Um, and I don't really know any of my students who thought that it made not that much of a difference having a storyline behind it to remember Sohcahtoa and what it stood for. But getting back to the topic we have at hand here, the cosine of C. Now, when I focus my attention on angle C, B is still the hypotenuse, because the hypotenuse is always the side of the right triangle that's opposite the right angle. It's always the biggest side as well. But now C is the opposite leg and A is the adjacent leg. So it's always with respect to the angle on which I'm focusing my attention. And that usually means one of the acute angles of that right triangle. I usually do not focus any attention on the right angle. It's usually one of the two acute angles when I start defining sine, cosine, and tangent. So when I do the cosine of C here, that's going to be adjacent, which is A, over hypotenuse, which is B. So for a different reason, the answer here is A over B. As far as the tangent of C goes, tangent is opposite over adjacent. So in this case here, with angle C being the angle I'm focusing my attention on, that's going to be C over A. Then when I go back to the secant of A, again, I'm focusing my attention back onto angle A again, where that makes A the opposite leg and C the adjacent leg. And I know that secant is related to cosine. Cosine would be adjacent over hypotenuse, which means secant would be hypotenuse over adjacent. So in that case, hypotenuse is B, adjacent C, so I'm going to have B over C.